The sample problem is going to cover the floor system for Plan 100. So as before, we will look at the actual sample problem itself, and then we will be referring back to this as we go through. So make sure you have this in front of you for taking notes. So when we are dealing with Plan 100, so far we have been dealing with the foundation system. So we have been looking at our foundation plan. But now that we're starting to move into the framing, we want to utilize more of the floor plan and pull measurements from here. We'll notice that we have a 26-foot width instead of our 26'4". Again, because of our brick ledge. That 4 inches will be allotted for the brick itself, so therefore the framing is only going to be 26 foot in width. Our length is still our 36 foot. It's a good idea to read through different information for the plans and specs. We see we have 2x8 joists at 16 inches on center, so that is our spacing. We have 3/4 inch tongue and groove oriented strand board, or OSB, and we are sitting on a treated sill plate. We have anchor bolts connecting that, and so we have the same on our wall section BB. It's just the different angle. When we are looking at our specifications, then again, the 2x8, the number 2 southern yellow pine is the grade and species. It is not necessarily something that we need to worry about at this point. We do need to know about the spacing. We have our 1/2 inch scabs on the beam. That will be for our blocking. Again, not necessarily something we're going to take off in this problem. We do have 2x8 header joists, double joists as required. This is what we are going to need around our stair opening, as well as underneath the refrigerator and other appliances within the kitchen. And then we have our cross bracing here. We have metal. We're going to treat them as wood in the sample problem. And we have our tongue and groove. So just recapping the information that is on the plans. Here we have additional information, the cross bracing. We are going to only have it between our common joists, not between our common and our band joists. So as we said, the band joists are what surround our foundation. The common joists are what are running in between. So if we take a look at the way our beam is set up, in our foundation plan, so we have our foundation walls, and then we have our beam that is running across. This is just for reference, not part of this problem as well. But we would then have our band board that runs all the way around the outside. Our joists span across the beam, so they're going front to the back of the house, and those common joists are the ones that are on the inside. If we want to look at it from a slightly different angle, we can look at it from the elevation view. We have the front wall, we have the back wall, we have our post and beam in the center. So this is looking from side to side of the house, front to back. So we can see that we'll have 12 feet to the center of the beam and then 14 feet to the back of the house. It's important to note this because we won't have boards that span the full 26 feet all the way from front to back. That would not be an economical choice. So we need to make sure that we choose boards that come in economical increments. 12 and 14 are very common sizes of boards, so we would use those for our joists. We have our band joist that runs around the outside, so on our this view we can only see them as cross marks. It means we're looking at the end of it. Our sill plate then is sitting on top of our foundation wall. It's a treated sill plate acting as the barrier between our concrete wall and then our wood framing for our floor. All right. So it also says refer to the specs for additional information. We've already reviewed those, so we are good to go to start with our sample problem. We're going to be calculating our band joist, common joist, miscellaneous joist, looking at our lineal footage, quantity, and board feet for all of those, and we covered how to calculate board feet in the lecture. We're looking at our cross bracing and then our floor sheathing, both in square edge and in tongue and groove. And then we'll get to our second problem after that. So starting off, we are asked to calculate the total lineal foot of band joists required for the floor system. So number one, we're looking at our band joists. Again, this is just the outside perimeter. Of our framing system. So we're looking at our floor system. We don't need to use centerline when we're dealing with framing, partially due to the fact that we'll be getting into pretty interesting decimals if we use our actual dimensions rather than our nominal dimensions. But also, lumber is not as a high priced item as concrete and block can be, so working with our outside dimensions is perfectly acceptable when we are dealing with framing. So the band joist runs around the outside of our perimeter for a floor system, so we can just do 2 times our 36 feet for the length, 2 times our width. Remember, it's the 26 foot. It is not our 26.4. We're dealing with the framing. So 124 feet is simply our answer for our band joists. When it talks about the specific quantity and lengths to be purchased in number 2, there are multiple answers that are possible for this, but again, we're just trying to think in economic terms. It's not just all about math. When we're dealing with our estimating, there is a little bit of logic that needs to go into it. So if we have 26 feet on our front, and 36 feet for the front, we have 26 for our side, and per the drawing I showed you, we know that our beam will run through the center. It's not centered on that 26. It is at 14 feet in the back and at 12 feet in the front. So it's very easy for us to see we can use a 12-foot board for part of the side and a 14-foot board for the other side to make up our 26 feet. For the 36, we can do different options for how we're going to split this up. But if we want to try and use, again, the most economical way, we can think of it in terms of what boards we're already using. We've already got 14 and 12. So we could use a couple of 14s and fill in the rest of it with an 8-foot board, or we're using 12s. 36 divides evenly within 12, so we can do a 12-foot, another 12-foot, and another 12-foot. So if we do that, we can see we have 3 12-foot boards along the front. We'll have the same along the back. We'll have a 12 and a 14 each on the sides of our structure. So if we're looking at our quantity, what we would list, we would say that we need a total of 2 14-footers, and we would need a total of 8 12-footers. So these are all 2x8 band joists that we are going to be purchasing at 14 feet and at 12-foot lengths. So it's just a matter of counting up your quantity. The reason it's important to do this, though, is more so if, for some reason, our dimensions did not divide evenly into a standard length of board. So if we had, let's say, 35 feet for the front wall, well, we can't buy a 12, and 11. They only come in 2-foot increments. So if we purchase 3 12s, that means we need to cut down this last board in order to meet the dimension. So therefore, what our perimeter is that we calculated isn't necessarily going to be what we actually purchase. Sometimes we need to purchase a little bit more than what we're looking for. So if we know we're buying, or purchasing, or we're buying, sorry, 2 times 14 feet and 8 at 12 feet, we know we actually are purchasing 124 feet. So in this situation, yes, the perimeter does match what we're actually purchasing. It is not always going to be the case. But what we're doing in number 3 is calculating the board footage of what we're purchasing, because we'll purchase in board feet, not necessarily in quantity or in lineal feet. So as we covered in lecture, board foot is simply taking our 2x8 boards that we know we're using, dividing it by 12, and that will give us our board foot per lineal foot factor. So regardless of how much lineal footage we're going to be purchasing, we can use this 1.33 board foot per lineal foot for any amount. But in this situation, we know we're going to be purchasing 124 feet, so our feet cancel out, and we are left with 165.3 repeating board feet. Just like with counted items, we always need to round up to the nearest whole foot. We cannot leave it in a decimal form. So we always round up, and we have 166 board feet that we are going to be purchasing for our band boards. So this is just the boards that go around our perimeter. So next up, we are going to be looking at our common joists. We have some drawings posted to Blackboard Learn for your reference. Here is our foundation system that is made for our floor system. It shows the band board that's going around the exterior, our 2x8s. We then have our joist, our common joists, that again are running front to back. They split along the beam, so we have the same amount running along the front as we're running along the back. The thing to make note of is that we do have this opening for our stairs, and we can use our floor plans to find these dimensions and truly understand what this opening size is. You can do that on your own time if you'd like to verify those dimensions. But what is important to note is that because we have this opening, there's actually going to be 2 joists subtracted from our count because of where these stairs are. However, we are going to just leave the count in there because we're going to add a double joist at the stair. So meaning we're going to put 2 joists and just sandwich them together. We're also going to do a double joist in our kitchen underneath the refrigerator where we have additional cabinetry, so some additional weight. It's not necessarily always needed in residential in this situation, but we're going to go ahead and throw it in there just so that our count can remain the same. So if we are looking at a counted item such as our floor joists, and they are repetitive, so this is what we're talking about. We're dealing with repetitive items, so something that is at some sort of spacing. Very common with floor joists, trusses, wall studs, rebar, and foundations. We have our foundation system. We have our 36 feet by our 26 feet. And again, when we're dealing with our joists, they are running from front to back. And yes, they will connect all the way from side to side as we go. So per the information we have, we know that these are 16 inches on center. So they are spaced at 16. What we can do is simply take our 36 feet and we can divide it by the 16 inches on center. It's very important that you don't mix up which direction you're going. So it is not the span that we're looking at the spacing. So it's the 36 feet, the length is what we're looking at, and it's generally going to be your larger dimension that you're using, but you need to make sure you follow the plans. And that, if we do, we will get exactly 27. Now be careful. This is not saying that we have 27 joists. What this is saying is we have 27 spaces. We have the 16-inch spacing that is defined, so that's how we end up with 27 spaces. You'll always need to add or subtract based on what you're working on, and depending on what the situation is will dictate which you do. Because our outside is going to be our band board, in this situation we're going to subtract 1, and we are left with 26 joists. A way to think about it is if we are using if we're running our joists like this. For simplicity's sake, let's say that there's a foot spacing between each of this. So 1 foot, 2 foot, 3 foot, 4 foot. We have 4 feet that we're working with. To divide by 12 inches means we get the answer of 4. So 1, 2, 3, 4 spaces. But it's clear that there are 5 joists here. So in this situation, in this demonstration, we actually added 1 to see the 5 joists. But if we labeled these 2 outside ones as band joists, you can see where we only have the 1, 2, 3 common joists on the inside. So even though they're made of the same material, we don't want to double count and buy extra material. So this is where we subtract 1 to make our common joists. So we will look at those again. This actually divided out evenly to a whole number of spaces. So let me do another example. If I can spell example. And let's say we have a 13-foot length, and we are putting 2-foot spacing on our member. So in this case, it could be a joist as well. If we take 13 divided by our 2 feet, we get 6.5. It is not possible to have a fraction of a counted item. And in this situation, a space is a counted item. So we have to round up, and we have to have 7 spaces. So you always need to round up so you have a whole number of spaces before you figure out what your joists are, whether you add or subtract. But what this is meaning is we're not going to then go back and resize all of our spacing to be into 7 equal spaces. All it means is in our dimension we'll have a 1, 2, 3, 4. And of course this is not to scale, but if we put all these out and what we're left with is a 0.5 of a space, it means that this last one will be only 1 foot. It'll be half the width of the spacing. So instead of saying that it is half of a space, which truly it is a full space, it's just half the dimension. So just keep in mind, whenever you figure out your number of spaces, your spaces needs to be a whole number. All right? Whole numbers is what we're looking for. But this isn't exactly what we're working on today, so don't worry about this. This is just an example to show you where you're at. But if we get back to our calculations, we just determined if we had 27 spaces and subtract out 1, we end up with 26 joists. We already determined that it is not going to be the full length. We're not going to have one board that is the full 26. The front is 12 and the back is 14. But for our calculations to determine lineal footage, we can just simply take the full dimension. So we can have 26 joists times our 26-foot length for each common joist, and we get 676 lineal feet of joists. And just like when we determined quantity previously, we want to look for standard sizes. Numerous times already I've said we've got 12 and we've got 14, so it's very easy to see that we'll have 26 running across the front that are 12 foot long, and we'll have 26 running across that are 14 foot long. We'll have the 24 that are considered our common in the spacing, but then we'll have the 25th one underneath the refrigerator, the 26th one that is at the stair. So our quantity, we have 26 at 12 feet, and we have 26 at 14. This is what we will actually be purchasing. We purchase it in board feet, so that's what we're doing in number 6. We have the same 2x8 for our common joist as we do for our band joists, so it's the same board foot factor. And we therefore have, again, 26 at 12 feet and 26 at 14 feet. You could simply put the 676 in there, but again, if for any reason we need to purchase additional from what our lineal foot counts for, we need to make sure that we're actually listing out what we are buying. So this comes to 901.3 repeating. So this would be 902 board feet. We have to round up to the nearest whole number. So we've accounted for many of our joists, all of the band joists, all of the common joists. We're also going to have miscellaneous joists. So around our stair opening, all of these extra shorter joists or doubling up of joists that are not the full length of the common joists are considered miscellaneous joists. So if we look at the miscellaneous joists at the stairs, again, these drawings are posted. We've just enlarged this area a little bit and shown some different colors to distinguish. We have tail joists, meaning they run from the opening to the foundation wall or from the opening to the beam. So they rest on either one of those. And then we have our 8 feet of our opening where we have an additional joist that is doubled up, so it is set against the band board. The band board's running the full length and only 8 feet of it is doubled. Lastly, we have double header joists per our specifications. So we have 1, 2 running at the back side of the house and 1, 2 towards the middle side of the house. And we can use this drawing then to calculate our quantities of how many boards we need. So number 7 is looking at our miscellaneous joists. We just said that we have 2 double headers. So we have 2 times 2 for a double, so 2 double, and each one of them is 4 foot in length. So therefore we have 16 feet of double headers we have to account for. We have the extra or the double joists at the band board or band joists. So this is the side of our stair opening, and per that we just have to pull the one dimension of 8 feet. So again, it is simply pulling this 8 foot dimension for that double at the side of the stair opening. And the last one we have are our tail joists. There are 2 that run from the opening to the foundation wall. Those are 4 foot in length. And we have 2 that run from the opening to the beam in the center that are 2 foot in length. So we have a total of 12 feet we're accounting for. So if we just add our three numbers together, we see that we have 36 feet in lineal footage for our miscellaneous joists. So now that we have determined the lineal footage of all of the miscellaneous joists that we will need for our stair system, we needed to figure out what we're going to purchase, and we determined that in number 8. Now there's multiple ways we can determine this. If we want to go with the same size of board, we can go with 3 12-footers since we have 36 lineal foot. Or we could also get different sizes if we wanted to only get one of our 12-footers, and then we could get 3 of 8-footers. Here we could do one of the 8-footers at the double at the band board, and then we could take the other 2, cut in half for our double headers, and we could use the 12-footer to cut for all 4 of our tail joists. Again, we could come up with the same cuts as long as we're careful for our 3 12-footers. It's just a matter of how many cuts we want to make, what kind of ordering we're going to do, but there's multiple ways of coming up with the right answer as long as it is justified. From knowing what we are going to purchase, we can calculate our board footage. As always, it is our 2x8 over 12 for our 2x8 joist. Comes up with a 1.33 board foot per lineal foot. Multiply that by our 36 feet, or if we decide to purchase 3 12-footers, either way, we come up with 48 board feet as the amount of board footage we need for our miscellaneous joists. We don't need to round up to the nearest whole number because it is already in a whole number. And number 10 simply adds up all of our numbers together. We have a 165.33 board feet from our number 3. We have 901.33 from our number 6. And we have the 48 that we just calculated in number 9. Gives us a total of 1,114.66, which of course we have to round up to the nearest whole number, 1,115 board feet. Now, if we went ahead and rounded added our rounded numbers, we would have used 166 that we got in number 3, 902 from number 6, and 48 again from number 9. If we add those all up together, we get 1,116 board feet. So as you'll see in the sample problem, both are listed, both are acceptable answers. If you wanted to save a little bit, you could use the unrounded numbers. It's always good practice to use unrounded numbers, but if all you have is the rounded number, since they needed to be rounded to the nearest whole number, you would end up with 1,116 compared to 1,115. That is not a big change.